Assalamu alaikum. This is 12th chemistry, and our today's lecture is about Frenkel defect. We have also already discussed this Schottky defect, as both of these defects are they are point defects, or we also call them as atomic imperfection, and both are stoichiometric type of these defects, because in both the cases we see that equal number of these cations and anions are missing. Now, as far as this Frenkel defect is concerned, it was discovered by a Russian chemist Frenkel in 1926. Now, this defect arises when an ion is missing from its normal lattice site or normal lattice position, and it goes to some interstitial site between the lattice pointers. Now, the existence of this vacancy or hole due to this missing ion, especially the cation, especially this cation, missing cation from its normal position, and it occupying some interstitial position. You can see here occupying this interstitial position over here. This is a cation, and it gets shifted from its original site to some interstitial site. Now this position, and that is, I have shown it here. Now in this case, the crystal, we see it remains electrically, it remains neutral, because we have got equal number of these cations and anions in the crystal. The only thing in this that happens in this case is that the cation gets shifted from its normal lattice site to some interstitial site. You can see it here now. So this remains electrically neutral. Now, as far as the conditions for this Frenkel defect are concerned, this defect occurs generally in those compounds where we see coordination number is very low, and number second is that it occurs in those crystals where the anions are much larger in size than the cations, because in this case we see that it is the cation that gets dislocated from its position to some interstitial site. Now, in pure alkali metal halides, in case of a pure alkali metal halides, say NaCl, KCl, we see that these defects are not very common, because the ions cannot get into the interstitial site in these spaces between the ions. This is because the cations are very large in size. In case of these alkali metal ions, they are large in size, so they cannot occupy this interstitial site. Now these defects can be found in case of silver halides, like we have got silver chloride, we have got silver bromide, or silver iodide, etc. Now, because of the small size of this silver ion, and now it can easily get into the space, or it can get into the space or the interstitial site. Now I would like to repeat this again, that in this case we see that this defect is seen in those crystals in which the cation is small in size than the anion. And as I have told you, the examples for this is, we have got this silver chloride or silver bromide. Now in this case we see, since cation, it being very small in size, it gets displaced. You can see here it gets displaced to this interstitial site, or it is a space between the two ions. So this is the crystal remains electrically neutral. And one more point is that in this case again, in this case we see the density of the crystal, it remains same, because no ion is missing anywhere. Because in Schottky effect we saw that the density gets decreased, because in that case we see equal number of cations and anions, they are lost, or they are missing from their normal lattice sites. But in this case we see only we see cations get displaced from their normal lattice sites to some interstitial space, so the density of the crystal remains same. And number third is that the entropy of the crystal, we see in this case entropy, as it is the disorderness, it again increases, because in this case, when this cation moves to some interstitial site, we see that a hole is created. This hole, now, which is created by shifting of this cation to this interstitial site, is being filled by the neighboring ion, creating another hole. So when this hole is filled by a neighboring ion, it gives rise to another hole, and so on. Now thus the entropy of the crystal gets increased. Then we have got another point, is that the dielectric properties of the crystal. Now the dielectric properties of the crystal increase because the attractive forces we see when the cation gets shifted from its normal site to some interstitial site. We see the dielectric properties of the crystal, they get increased because the attractive forces between the ions now they between these ions they get increased. So whereas the we see the dielectric properties get now increased, whereas in case of now this does not happen in case of these in case of this short key this defect. One more thing is that the electrical conductivity. Now the electrical conductivity of the crystal also increases because there is rapid formation of holes due to the migration of ions. So this is about this Frenkel defect. So in Frenkel defect, there is only the dislocation of the ion, and that is especially this cation from its normal lattice site to some interstitial site. Whereas in that case, in case of this Schottky defect, there we see the equal number of cations and anions get lost from their lattice site. So this is for today, and in our next chapter, we will take up this magnetic properties of these crystals. So this is for today. Thank you.